In a joking sort of way, I'm going to define the standard version of the thesaurus and then the pro version of the thesaurus. And the common version, or the standard version, is the one that most people use when they pick up a thesaurus and they look up words. You can see on your screen here a picture of thesaurus.com. And thesaurus.com is exactly that kind of thesaurus. It's one that shows you a term, allows you to find its synonyms and its antonyms, and you can click around through the thesaurus trying to find the appropriate word for a particular situation. So what's interesting to us, I think, is to model. Oh, here comes Charlie. Charlie's come to visit us. The thing that's most useful to us, okay, now you can go away now that you've come to visit. The thing that's most interesting to us is to try and model that kind of thesaurus using a schema. Right? That's what we're all about. We see an access structure, we see something in the outside world, and we start to model it using our tools of schemas. So if you look in the second screen here, we see a zoom in on one entry, and that entry is called information. We can see that it's a noun. It has a definition, fact or news. It has a set of synonyms, and you can guess that those synonyms are all links. So if I click on one of those synonyms, it'll take me to that term, or that entry in this case. So they're called entries here, but we're gonna just standardize on that vocabulary of term. And then it'll give you the antonyms, and then there's a source for it. So how would we model this kind of thesaurus? Well, I think it's pretty clear that we're going to need things like the name of the term, what part of speech it is, what its definition is, and then some way of specifying synonyms and antonyms. So if you look at the schema that I put together here, you can see one model. Now, not that this is the only model, but this is a reasonable model of how you might go about taking this thesaurus, reverse engineering the information structure behind it so that you can A, understand, B, critique, and C, maybe create one of your own. Okay, so we have the common thesaurus, that's the root element here. Under that, we have a set of terms. Each term has an ID, and as you're beginning to, I hope, internalize, if it's an important thing, an important element that we have to get back to, and particularly if we're going to consider it to be an item of information, as the term is here, it'll get an ID. So, backing up for a second, the way we're going to model this thesaurus is it's a set of terms, and each of those terms is an information item. And the term itself is the model of the term, or what we're looking at here in the schema, is the information type. If our thesaurus has 1,000 terms in it, that's 1,000 items, all of the same type, and that type is term. Okay, so each term has an ID, each term has a part of speech. This, by the way, is a schema from another product. It's not from Oxygen, and so we're not seeing some things that we would see in Oxygen. For example, that part of speech is a string, and part of speech has an enumerated list, right? There's only so many parts of speech, nouns and verbs and adjectives, etc. And so we would implement this part of speech as a string that has an enumerated list. And if that's strange to you, go back and look at the topic on enumerated lists and refresh yourself on that, because it's an important topic or an important idea. Okay, so a term has an idea, a term has a part of speech. You may well be asking, why did I put the part of speech as an attribute and not as an element? And the answer is strictly a matter of style. I decided to make it an attribute, and so it's an attribute. I certainly could have made it an element as well. I would have definitely made it an element if it had multiple parts of speech. In this case, one of the constraints of our schema is every term has a single part of speech, and we know that because part of speech is an attribute, and you can't have multiple attributes. Now, just as a little caveat, you can have something called an ID list, or you can actually pack more than one value in an attribute, but as far as I'm concerned, that's pretty bad form, and we'll never do it. Okay, so a term has an ID, term has a part of speech, term has a name. In this case, the name for this particular item is information. That's the word itself. Could be a couple of words in a row. Like, for example, you see one down here called chapter and verse. And chapter and verse is multiple words, so that name could be multiple words. It has a definition, and we're going to choose in this case to make the definition very simple. You can see that our definitions are really pretty terse. They don't require a lot of internal formatting. They're not going to be mixed elements. They're really just going to be strings. Okay, so that definition is going to be a string. And then I have some number of synonyms and antonyms. Right? I can have as many as I want, and so you see in this sequence that I can now have from 0 to as many as I want synonyms, and from 0 to as many as I want antonyms. And not only are they synonyms and antonyms, they're the IDs of the synonym term and the antonym term. So we have a synonym ref ID and an antonym ref ID. And what are those pointing to? Those are pointing to other terms, right? So when I say it's a synonym ref ID and it points somewhere, that means that it's an ID ref data type, even though that's not shown on the screen here. I apologize for that. I should have retaken these screenshots, but next time. It's an ID ref data type, and since there's really only one ID in our entire schema here, it really has to point to the term ID because there's no other ID for it to point to. But it makes sense that it points to a term ID. So this might on the surface seem a little strange. We have a term pointing to another term, right? It's not pointing to some other element in our schema. It's pointing to one of its own kind. It's pointing to another term. But that's not unusual once you've kind of thought that happens and get used to the fact that happens. Okay, so term has an ID, part of speech, name, definition, and some number of antonym and synonym ref IDs. So what's going on here from an access structure standpoint is we really have one access structure that's represented here explicitly, and that's associations. We have two types of associations, synonym and antonym associations, and those are represented by the ref IDs. Now, in addition to that, I'm sure you can see that we could easily create indexes for part of speech if we wanted to. We could sort by part of speech. We could also sort by name. So we have two alphabetical indexes also at our disposal here, two things that we can use as alphabetical indexes. And of course, in the common thesaurus, it's the alphabetical index of name that really counts. I don't think I've ever seen one that has an alphabetical index by part of speech, so you can look up all the nouns, all the verbs, all the adjectives. I don't think they have that. So the usual way we would do this is alphabetical index by term name, and then we would have cross-referential links to synonyms and antonyms. And in fact, that's exactly what's on the screen here.